Okay, very good afternoon to everyone. I don't know why you people have been attending only 4 to 5 people. So let me give you a chance to talk with me for a while before going to the next one. So I have given some chance to you to talk with me for a while. Why you people are not attending classes regularly? Yes, very good afternoon to everyone. Why you people are not attending classes regularly? You could unmute yourself and you could talk with me 1 or 2 minutes. Then we'll continue class. Okay, you are not interested to speak with me. Okay, no problem. It doesn't matter for me. Okay, it is my responsibility to give the class. Okay, we'll see. Soon we'll come to the college. We'll see what would be the next steps we're supposed to take into consideration. Okay, however, so already we have seen so these things in our previous classes. So in previous classes we have been already witnessed all these issues. Let me clear up them. Then I'll come back to you. So come to this area. Let me clear up everything. Then because if these things will be there, you will be get confused. Okay. However, so we have seen all these things in AES. With respect to AES, we have seen everything. So advanced encryption standard will always focuses upon so these 4 different types of layers. So these layers have been discussed, and what is a substitution has been already discussed by us, and what is shift rows also discussed by us in the previous session. So let us come across this one here. These 4 layers will be byte substitution, shift row, mixed column, and key addition, and so on and so forth. Everything has been discussed here. So these are the points we have discussed in this particular perception here. So all these points have been discussed in the previous class. Okay. So this is what kind of operations which could be took place by 4 layers at a high level point of view. We have been discussed these things here, and uh, and also discussed this particular key substitution layer. So key substitution layer does have so 16 by 16 S box will be there. You are expected to operate so a parallel of 16 S boxes for doing some kind of crypto encryption process. All these 16 S boxes does have the same kind of so table which is being available here. So based on this one, how the data will be extracted is also seen by us in the plain text. As far as our convention in AES, we have taken A will be the plain text, and so C will be the cipher text. Yet in plain text, so C2 will be the input of your plain text in the sense C will be represented 1100. So it is C. 2 will be represented so 0010 will be 2. However, this could be considered as rows, and this could be considered as the column we have already taken into consideration, and C will be here, and the column will be this one. So based on these two values, we have been acquired this particular value. 25 will be the value which is been there, and everything. So S box will be always taken in terms of the hexadecimal form, in terms of hexadecimal form, 16 format here. And you need to convert this particular value again into this binary, something like this 25. 25 will be converted into 10, followed by 5 will be 0101. Like this, you have to convert. Okay. In this way, we have taken into consideration. And very important rule. So commutative law, very important rule would not be true. We have already proven this one. So byte substitution of A plus byte substitution of B, two different bytes will be taken. So these two will be added together, will not be the same as this one. It's also already we have now we would like to go ahead and discuss something about diffusion. What is diffusion and how this diffusion could be gets happened today? We'd like to have this particular look. Okay. In diffusion, after taking this particular shift row, after taking shift rows, so we would like to consider one particular operation, that is mix columns. These mix columns will be taken into consideration something like this. So shift rows will be taken second row of the matrix. Second row of the matrix must be, so shift right towards right for 3 bytes. Third row will be shift right towards 2 bytes, and fourth row will be shift right 1 byte towards right. Something like this would have been operated here. Based on this one, it could be taken like this. This is the initial state input matrix. And if you take this one, so it could becomes like this. So no shifting is happened at first row. Second row could be taken 3 bytes. 3 bytes in the sense, so B9 is 1 byte and B13 is another byte, B1 is another byte, something like that. Okay. So after shifting thrice, so it will become something like this. So B1 will be moved to last, and B13 will be here, and B9 will be here, and B5 will be somewhere first in the first location here. And the third row will also be shifted towards 2 bits right, 2 bytes right, and the fourth row will be shifted to so right side for 1 byte. So that this is the output here. So after taking this particular output, how mixing is being happened? That is the point here. That is the point here. So mix column sublayer, how this could be gets happen? Mix column sublayer could be taken. So Galileo's float value of 2 power 8 using this particular polynomial additions, subtractions, and multiplications we would like to perform. Okay, Galileo folds so 2 power 8, or otherwise Galileo folds polynomial additions. So additions or subtractions or multiplications could be took place here. Either addition, subtraction, or multiplication, this will be gets operated. There is no problem. Addition will be directly add the points, and subtraction will be you have to subtract. There is no problem. Multiplication also directly multiply. There is no problem. But if you at a over, mixing kind of issue, this mix in the sense, what do you mean by mix column in the sense? Mixing will be taken, so exclusive or operation. We will see, we will be witnessed very soon what is mixing and how mixing is being gets happened here. Look at this. Mix column will be always so linear transformation which mixes so column by column within the state matrix. Column by column with the state matrix, and it does have its own idea how this could be gets operated here. Okay, so it is the major diffusion. Diffusion in the sense permutation actually. It could be always been considered as permutation. Okay, so permutations could be how these permutations could be gets happened here. Let us have a look here. So these things will be mix column of B. A C will be get something like this. Mix column of B will be equal. What is the output of the mix column? So that is C. How this could be get here in the sense. So here we have to operate a mix column. Okay. So totally 32 bits input will be taken, which is in terms of B here, as we have specified in the previous shift row. And then after taking this particular mix column, so the output which we have to get here will be considered as C here. Okay, then C will be sent to key addition. The C will be sent to key addition. And what is the point you need to consider here? You need to consider C0, C1, C2, C3. Already we have seen, so first 4 bytes and the second 4 bytes, third 4 bytes, we have been taken something like this in AES, while encryption will be get started here. So whatever the after shift rows and after mixing and everything will be happen here. First one is So confusion, first confusion after shift rows and mixing will be happen here. Finally, you will get a C0, so C1, C2, C3. Whatever the mixing you could be happen, however, whatever the names it could be, how this could be mixed here, that doesn't matter here. But the values, finally, outcome values will be C0, C1, C2, C3. And next set of values will be C4, C5, C6, C7, something like this only could be taken into consideration. And these will be always taken. So 2 into so B naught for C naught will be equal to, let me display this one also. C naught will be equal to, so 0 2 into B naught, okay, then 3 into B5, then 1 into B10, and again 1 into B15. Okay, look at this, look at this. And if you operate in such a way here, so what are the values of 0, 1? Let us look what is this particular value, what is this particular value, and what is this particular value and this particular value. How this particular, because I have already given that, so GF 2 power 8 polynomial addition and subtraction multiplication could be gets happened here. So that is why directly, so 1 and 2 could not be taken into consideration. 0, 1 in the sense everything will be considered something like this. It will be so considered in polynomial. It will be considered as 1, and 0 2 will be considered as x. Okay, 0 3 will be considered as x plus 1. Okay, x plus 1. I have given one example also for our kind information. This is x plus 1, x plus 1. Okay, based on that, we would like to operate and we would like to get the operations here. So let us have a look here. Galileo's field. Galileo's field kind of operations could be took place here. Either it is addition, or it is subtraction, or it is multiplication. Division cannot be gets operated here, and followed by exclusive OR operations. You must remember what is exclusive OR in the point of view. Okay, however, we will see. In the previous slides we have been taken, let us move backward here. Yes, here within this particular area only. So look at this. So in the previous slide, AI will be equal to C2. AI will be equal to C2. Therefore, we got the value as 25. We got the value of 25 here. So if you take this particular value into consideration, so B will be get 25 as output. B will be 25 as output, and this B will be sent to mix column, and output of mix column will be C0 or C1 or C2 and so on. For example, so B0 to so B15, all these values will be taken, so 25. For example, we would like to consider in such a way, 25, everything is 25 and so on. So 25, if these things will be there with us, then how C0, C1, C2, C3, C4 values will be calculated. Let us have it here. Hope that you understood what I spoke to you, what I told you here. For example, so B0 to B15, all bytes will be 252525. For example, it could be the specific input for this particular mix column. Then what are the outputs here? How you could calculate here? Let me go ahead and let me show you how these calculations will be done here. Mixed column sublayer example could be seen like this. A will be equal to C2 in hexadecimal, and here then substituted value could be taken to something like this. So S box input will be C2. It is in terms of C2, and you finally get based on the table S box table, you get this particular thing. So 25 will be always calculated by using Golio field, so 2 power 8 format. So let us have a look here. So here, as far as the previous slide, okay, this one, look at this. 2 into B0, 3 into B5, 1 into B10, and again 1 into so this particular B15. So these are the values so we have to consider. So for our kind information, just we spoke that every value, B0 value is 25, B5 value is 25, it is 25, and it is also 25, and it is also 25, and it is also 25. Everything is 25. For example, we have taken the example in such a way so that we need to identify. So 25 into 2, so 25 into 3, 1 into 2, sorry, 1 into 25 and 1 into 25. Wanted to identify these values, how this could be acquired here. Let us have a look here how you got this particular value. How you got this particular value here in the sense 25, it is not binary actually, it is hexadecimal. Okay, 25 is hexadecimal value. So 2 will be written 0, 0, 1, 0, and 5 will be written 0, 1, 0, 1 because it is one hexa value. This is another hexa value. And if you take 2 powers as the values, 2 power 0, so 2 power 1, 2 power 2, 2 power 3, 2 power 4, and 2 power 5, where exactly ones will be there. So the coefficient value is x and the power value is 5. So therefore, x to the power of 5, so plus x square, because 2 power 2 does have the value here. Then followed by 2 power 0 is 1. So therefore, that equal to 1 here. So in this way, we get the value. In this way, we got the value. Okay. Then already we spoke that so 0, 1 value will be, as per the matrix, 0, 1 value will be equal to 1, and 0, 2 value will be equal to x, and 0, 3 will be equal to so x plus 1. These are the Galileo field values which have been taken into consideration by us in the previous slide, previous discussion. Okay. Now I'd like to calculate this one here, x into x power 5, that is x power 6, then x into x square, that is x power 3, x into 1, x. We don't know about this one because polynomial expressions, we are very familiar with them. And then 0, 3 into 2, 5, x plus 1 into, so x power 5, x power 2, and 1 here. So if you calculate this one, you got these values here. You got these values. Okay. Then what exactly we are trying to perform? So 0, 1 into, okay, let me write here. 0, 1 into, so 25, this is first one, plus 0, 1 into, so 25, this is for second one, plus 0, 2 into, so 25, this is third one, plus 0, 3 into, so 25, this is fourth one. Because B0, B1, B2, B3, all these values will be considered as 25. That is why I am taking 25, 25 continuously. Okay, so multiplication is gets over. 1 into 25, 1 only. So 1 into 25, 1 only. 25 in the sense polynomial multiplication. 1 into 25 in the sense x power 5 plus x square plus 1 into 1 will be x power 5 plus x square plus 1 only. So again, 2 into 25 in the sense 2 into x power 5, I mean x into x power 5 plus x square plus 1 will be x power 6 plus x cube plus x. And then 3 into 25, that is x plus 1 into x power 5 plus x square plus 1 will be this much. These are the values. Now we have concentrate to operate addition here. This is first addition, second addition, and third addition. Let us add all these values here. Hence, so 1 into 25 will be x power 5 x square plus 1. Similarly, 1 into again 25, the same values. Similarly, 2 into 25, x power 6, there is no x power 5. As far as this particular expression, x power 5 is not there. X cube is there actually. X square also not there. Plus x is there, but plus 1 is also not there. 3 into x power 6, x power 5, x cube, x square, and x plus 1 here. Okay. So let us have a look here how this particular value could be operated, how this particular value could be get here, how this value has been acquired here. Let us have a look here. So normally, if you operate exclusive OR operation, so how this could be taken? So one exclusive OR of 0, 0 will be equal to 1 here. Okay, 0 exclusive OR of so 1 will be equal to 1 here. And conversely, so 1 exclusive OR of 1 will be equal to 0. So 0 exclusive R of, so 0 will be equal to again 0. This is the logic diagram what we know regarding to exclusive R. Look at this. I'd like to specify what exactly the points will be. What exactly the point will be. So x power 6, x power 6. Where exactly you have to write x power 6 here. X power 6 does means, so here it is 1. So exclusive R of 1. So x power 6, x power 6 is 1. Within this place, x power 6 is 1, x power 6 is 1. 1 exclusive R of 1 equal to 0. So therefore, there is no x power 6 value here. So x power 5, x power 5, x power 5. 3 times x power 5 will be there. Existence of each x power 5 will be 1 here. 1 exclusive R of 1 exclusive R of 1 here. That is the meaning actually here. This is the meaning. So 1 exclusive R of 1 will be equal to 0, and 1 exclusive R of 0 will be equal to 1 here. So that is why we got this particular coefficient. Okay, in this way we got x cube plus x cube. In the sense here also the same formula. 1 exclusive of 1 will be equal to 0, so therefore there is no x cube so value here. So it is existed for thrice, so therefore 1 exclusive R of 1 exclusive R of 1 will be equal to, these two values will be equal to 0. 1 exclusive R of 0 will be equal to 1 here, so it could be gets existed. So x exclusive of x will be equal to 0, because 1 exclusive of 1 equal to 0, so that here we don't have any value. Then so 1 exclusive of 1 0, 0 exclusive of 1 will be equal to 1 here. So therefore finally we got the output x to the power of 5, so x square, so plus 1 here. If you convert this particular value, so it could be, so 0 followed by, so this is 5, 4 is 0, 3 is 0, 1 is 1. So I mean second position is 1, and then third position, first position is 0, first position is 0. Wait for a while, I'll come to you. Okay, first position is 0, and finally 1 will be there. So this is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Yes, I have mistakenly written the 0 there. Mistakenly written this particular 0 here. It could be written as 1 here, 2 power 5. 2 power 5. Therefore, the value could be seems in such a fashion. The value could be available like this. The value could be available like this. Look at the value here for a while. So 1 0 0 1 0 1. If you take, if you convert this particular value into hexadecimal is always expecting to so convert. Group for 4 digits, 4 binary digits 1. So this is 1 4, and this is 1 more 4. Nothing is available here, so that you will place here. So it is called as 2, and which is called as 5. So in terms of 16 digit, like this you get C of Y. How you could get in the sense? So C2 of XA will be get to 2 5. How it could be get in the sense? In this way. In this way we got this particular value. Okay, like this. So you have to calculate mix column sublayer. So I'll take one more example by tomorrow, because I don't have time. I don't have time to prepare. So this key addition layer is not there, because so today, yesterday, and today I'm full busy with. Looking forward for projects of your seniors, so that I don't have the time to prepare this one. So it was not prepared by me. Tomorrow I shall prepare, and I'll come to you. So with the key addition. So before that, I'll give you one more example, one more same kind of example, which could be gives you different kinds of values, not exactly 2 5. We will take some other values, and I'll give you so complete example for you. Okay. So this is for today's class. Okay. I don't know why the people are not interested to attend. I don't know why. So we'll see. We'll see what could be the reasons. We'll see.